Okay. Yeah, I was also trying because I haven't visited this chart last few lectures. So I'm trying to educate myself quickly here. Now, in the data types, there would be two kinds. There'll be qualitative, which is when we would like to look at different types of qualitative data or how the qualitative data can be identified. But to tell you the truth, um, I would rather, okay, I wouldn't confuse you with what is qualitative and what is quantitative here. Let's look at data in general. Um, so, not to worry about separating it into these two different types. So we'll start with binary, nominal, ordinal, and then look at continuous and discrete data. So we'll just all different flavors of data that we feel could be somewhat useful in identifying um, these data types with the strategy uh, of how you would be using them for analysis or analytics. So let's move now um, with the next one. The quantitative data, you're all familiar with it, and we've discussed it off and on. It is just a definition that is telling you what qualitative means. And best in these examples, qualitative could be personal observations, which could be another type of information gathering that would involve your own opinion, perhaps your own mind to how you would interpret certain situations or certain activities or acts, including what is covered as trends. Or no, not the trends. I'm sorry, using what is it? Personal observation could be social experiments, for instance, where you are looking at different aspects of interaction between individuals or between objects and individuals and so on. So those are personal observations. Emotions, very hard to interpret, translate into data of sorts. Then you've got sentiments, feelings, interviews. Sentiments are subjective. Sometimes they're so personal, and they could be a bias involved in there, or there could be a preconceived notions. So many elements that play the part in qualitative data that link from the word sense, you can call them sentiments or emotions. Then you've got interviews, which is again something that is interactive, depending on who the observer is versus who the subject is. um, Depends on what transpires as a conclusion or as a situation that translates into gathering of just information pieces, um, or solving a problem, getting opinion. So those would be the outcome of interviews, um, and so on. Anyways, these are just examples. And what is the issues behind this is that um, how are you going to capture that information and use it so that it is easy to interpret, or there is somewhat a kind of a calculation that you can do to justify the conclusions. So this is where the qualitative data is more challenging. Then we've got quantitative data. Obviously, it's mostly it's quantitative, therefore it is numeric in nature, and shoe size, height, and so on, measurements and dimensions. So quantitative is a lot more easier to work with, and it is more definitive. It's not discretionary, it's not biased on in any way. It is the figures that tell the story. So quantitative is of that type. So between qualitative and quantitative, there could be another type of data which we call mixed data. That's not mentioned here. Mixed is a combination of both qualitative and quantitative. Um, in certain type of questions would bring quantitative results, other type of questionnaires for, which is what you obviously, we haven't gone there yet, but that's the questionnaire referred to as surveys that you conduct. So, that may also have a combination of qualitative and quantitative data streams based on how you present those questions. Then we've got the quantitative data that can be divided or can be now this is the part where we are learning the technical language uh, of how you are going to name a few sets of data. um, and this technical language is not as important if you are not doing any formal research, but rather the research is really not asking you to be more detailed or be specific enough that it is actually being run into complicated softwares, or there are certain type of softwares which is these days what we use. We don't use mathematical calculations as such. We sort of process everything um, through those softwares. So because unfortunately we don't have the example of softwares, but just so you know that this distinction or this categorization of data, which belongs to a class of quantitative data, is important for obtaining certain type of uh, information that can be used in those softwares, or those applications would ask you to identify the data as being continuous or discrete, for example. And if it is continuous, then you're going to plug in figures or give it numbers which belongs to continuous data types. This is I'm just giving you an idea of where it can connect and you find it more useful. So continuous data, the first thing is that uh, rather to just go through the definition, let me explain it better with the examples. Continuous data is something which is exact data or which is mathematically correct to the nth value, or the fractionally correct, meaning that a whole number, which is 1, 2, 3, 4, are whole numbers. Anything that divides those numbers or the whole numbers follows a dot and a fraction. So if, for instance, we have a driving laps, a lap, I'm sorry, not lap, that's, when the cars are doing the laps, they are measured as 1 meter in 12.34 seconds. So basically, it has two values, but at the same time, most important is that it is a continuation of something which requires precision to the nth value or the fractional value. So 1 meters in 12.34 seconds. This is what we call continuous data. And then it says another attribute of a continuous data is that it can have number value with any number of desired decimal places. This data is used in events that require time as major part of how the event works and gets ranked. So these are slightly more complicated when you are using something as um, indicated with this lab, which is marked, which is given a value of 1 meter in 12.34 seconds. Um, and discrete data, on the other hand, is something that cannot be measured in fractions, or you don't need it to be accurate to the value that follows a decimal sign. For instance, you cannot have 2.5 kids or 1.3 pets. So I guess when you are talking about discrete data, you will make sure it is a whole number. Idea of how it is explained as 2.5 and 1.3 can be translated when you look at the definitive result of your query or definitive questionnaire that has questions posed as um, as answered either as yes or no, or male or female, or you know big and small. So these are, the two type of values that would somewhat fit in the discrete data situation, meaning that it is either yes or no, or it is a whole number, and nothing that can be broken down into fractions. So between continuous and discrete data, this is the distinction. That's the only thing that we have to be mindful of when we are doing quantitative analysis. Uh, you would be asked to fill in or to prepare the application or your measurements or your analytics by first defining the type of data, or whether it is going to be continuous or it's going to be discrete. You'll find out later when you actually are using those applications the usefulness of this knowledge. However, it is one of the ways in which we classify data types in quantitative analysis. And there could be five more, but we don't need them right now. They could be more of variations of continuous data and also discrete data. But the major concept or the main classification is just only two types: quantitative. Now, in qualitative, there is binary, nominal, ordinal data, interval data, and ratio data. Now, binary data, and like I said, don't be worrying about the qualitative nature, because sometimes binary data can also be quantitative. Nominal can also be quantitative. So in the books, they have defined it under qualitative, but in order to avoid any kind of confusion, I would just say just focus on the types that you've learned: continuous, discrete, and now you're just learning binary, nominal, ordinal. Okay, so the binary data is two sets, like data for it to have any value generally, and because it is relational and it has to have an attribute, or it has to have a relationship to make sense in terms of comparison, to give it the value, you definitely need uh, more than one value. Binary data means just two data or two instance. Like binary can be the previous one, where you have yes or no, male, female, the one that I told you with the discrete data. Then we have nominal data or unordered data. There is unordered or unstructured at times we call it, but there is another type which is called raw data. Uh, that's not what I'm going to explain in detail, but let's suppose nominal can be unordered in a different way, not exactly the same as unstructured or raw data. And I'll tell you what it means really. So when you look at the nominal part, binary is two, mutually exclusive is another way of explaining it. Exclusive means could be opposite. One is yes, the other one is no. So both are opposite of each other. Black and white are opposite. So that is binary. I am looking at now unordered data. These are the set values that don't possess a natural ordering. Let's understand. Okay, let's take an example of the color of a smartphone. Okay. One color is unique in its own way, because a blue cannot be green and green cannot be yellow. So they are given an attribute which is very specific and identifiable with that color only. And yet, if you want to put that data as if you are comparing which one is better or which one is less or more, you cannot do that with the colors. You can't say blue is better than green or green is better than red or yellow. Each one of these colors are unique, and has a quality which is part of its value or which makes it distinguishable. Not as a number, but assume it to be colors. That's where you're going to be focused on. So, a lot of times, the unordered data that would be asked of you to put together would mean that there is certain limitations to how much of unordered or nominal data can be can be compared relative to each other. Uh, Again, red is greater than blue is not something that you would want to put as a question or even pose it as a type of information that makes sense because these are colors. The gender of a person is another one where we can't differentiate between male and female as being which is better or which is you know greater or whatever the relationship that you want to give it to uh, give it an added value or to uh, make any kind of attribute or a relationship in the databases. Male is a male and female is a female. Nothing more you can attribute that would be able to mm, uh, get you a relative figures. In the qualitative sense, it is fine that you can pose these as unordered or nominal data as part of your questionnaire, but at the same time, you cannot use it in quantitative analysis to give it a relationship with relationship in with reference to what could be the differentiator. The differentiator does not exist. It is either male or female. So this is unordered or nominal data. Then we've got other examples for the same because sometimes students get confused. Even though it is easy to understand when you look at it from the uniqueness of how each represents a value that cannot be diluted in any way. Um, Example of a nominal data. If you have to pose a question, for instance, what color hair do you have? Okay, so it's either brown, blonde, black, rainbow, all of these. But because they are to be organized as or considered unordered nominal data, means that brown cannot be blonde or blonde cannot be better than uh, brown, or you cannot, they have their own uniqueness and specifications that cannot be compared with. Uh, what's your nationality? So you've got all these nationalities. So these are just few examples. Yeah. Ordinal data is something that is relative and can have a relationship because when you're creating charts or when I have to do some sort of data visualizations or anything that is bringing me graphs or something that is on the visual side that I can compare the two different values to have a relationship such as bigger than, less than, greater than. I would need an ordered data or ordinal data and not the unordered or nominal data. So ordinal means here is an example. If we consider the size of a clothing brand, then we can easily sort them out according to their name tags in the order of small, medium, and large. So small, medium, and large could have, different values with relationship to each other, meaning that small in European size could mean 12 or could be some other way of how it is representing small as part of the European sizes versus US sizes. The large in US is too large. You don't find large enough sizes, let's say, in some part of Europe. So these small, medium, and large, they are ordered data, or you could say that have a relationship capacity in terms of its surrounding or how it attaches or gives a meaning based on certain situation, certain environments. Then we have another example somewhere here. I think um, the grading system while marking can, in a test can also be considered as an ordinal data. See, A plus means something, B grade means something as in academics grading system. Okay, so okay, that's all we need to know. Then we have examples of ordinal data, just as we did with nominal. So ordinal data examples are questions like how likely are you to recommend our services to your friends? See, we did short, medium, or tall sizes, eh? Scale we can use as another type of ordinal, meaning that now you are you are trying to figure out techniques of how to pose questions or the certain type of questions that will uh, require for you to gather ordinal data through uh, the the questions that you would prepare, which are going to ensure that you are able to collect it as an ordinal data. Ordinal means that it has a way of translating something which is of qualitative nature into uh, variants of or how would you say, not the variant, but let's say have different ways of expressing the strength or the extent of something or the scale of something, small, medium, large. This one that we are talking about, another example in survey questions that ask us to rate them 1 to 10 scale, because here the question is the type that might require some sentiment analysis or some feelings or something that people cannot exactly quantify but rather express in terms of sliding scale of how they would interpret it or how they would think of it, to the best of their uh, you know personal liking. So if 1 to 10 is something that you get to see, it's because you're posing a question or you need an information that demands that you put together a questionnaire, or the nature of the question is such that it only brings qualitative results. But then there are techniques of how you're going. The sliding scale is one of them, or the scale of expressing something 1 is to 10, or stars. Rating stars could be another way you could see that's everywhere where you give your opinion by just clicking on the third or the fourth or how many stars you want to give it. The example is easier to explain what I'm saying. How likely are you to recommend our services to your friends? Okay, so how likely is a good question rather than asking, would you say yes, you like, or no, you don't like? Because at times people don't have a definitive opinion, or they somewhat don't want to give extreme opinions, depending on the the topic itself or what the question poses. You may not be able to answer as yes and no. So binary won't work. Ordinal is the answer to that. And ordinal in the qualitative way requires for you to understand language of how you're going to rate it. How likely, very likely, less likely, neutral, unlikely, very unlikely. So these are, the ordinal data, and these are structured, or you could say that these are organized. Organized in the sense that it uses similar kinds of sentiments, but giving it different values. One is for very likely, two for likely, and so on. So these are the ordinal or continuous data, and it can be compared, or it would have some sort of measurement to it, um, and easily can be translated from the scaling factor or the wording that you use, which would give it the number, or can be translated into numbers. Then we have interval data. This is the type of data which will not give you a conclusive result based on one set of event or a single event, meaning that the objective of your search to get the satisfaction of knowing that you have accomplished or you've got the right results may not be brought in by just one or two instances of the numbers collected or anything that you collect, even in qualitative sense, may not be enough unless you have a huge population or a large sample to be able to make that decision, and therefore the range increases. Interval data is that sort of information. Say, for example, in the Olympics, I don't know where this score is coming from. Let's suppose gymnastics, and just one performance is not enough to rate the athlete that if they have, either gotten a final score or one verdict, but rather it could be the same athlete doing a sequence of or series of contesting performances that would bring a collective result that eventually can be aggregated or averaged out. For instance, one in the one performance, the same athlete got 6.0, second performance 6.5, third 7.0, and 7.5. So all these are the kind of data or interval data that demands or that ensures that, with the collection of all of these numbers or different performances, and these are not exclusively, interval data is not only for numbers itself, but it could be other things. It could be qualitative type of information also, like frequency of, let's say, so many people from such and such country in one semester versus another semester. So that would also be something that you can be calling interval data, because then you're, going from one period to another, or from one, if you compare it with the performance, one performance to another. So it'll be okay, Isha. See you next time, and hopefully you'll have a good weekend, well rested. We'll see you on Monday.
Yeah,
Take
thank
care.
you.
Bye.
Thank you, Mr. Naveed. Sorry I had to
Thank you.
discontinue, but because
No,
I'm
no,
not
no, no,
really feeling too well.
don't worry about it. Even I am not feeling well after I delivered these kind of lectures. It's very complicated for me also. All right. And you have to listen to it.
Thank
So
you.
thank you so much. Enjoy your weekend.
Thank you.
Hopefully you'll get well. Bye bye. All right. Next, scores. See, if you don't, if you have a question, any one of you, and you feel that I've not been able to explain something well enough, please raise your hand and tell me right away, and I'd be happy to go back to it, because at times, and because it's not only sometimes complicated, but because it is a new subject for many of you, and also because it's a lot of different concepts we're discussing in just 2 hours. There could be this situation. So if you uh, feel like asking a question during the lecture, raising a hand, I'll be happy to answer. Another example of interval data is shown here in Celsius, for instance, in the scale of measuring the temperature. 20 degrees C is warmer than 10, and the difference between 20 degrees and 10 degrees is 10 degrees. Now, the way it is written, it sounds confusing, but basically what it's saying is that at the time when you are actually doing an analytics or analyzing something, and you're trying to mathematically translate that into something which could either be visual charts, or a differentiation, or a calculation of sorts, you may want to keep in mind or know that the reason why you are doing these is because you have a bunch of interval data that is not it's not delivering something as a compelling outcome of your computations or analysis, you would probably want to mention or relate that to the nature of data being interval data, or the sample is not big enough, or it is too short, or the sample required some sort of calculations to for you to come a differential number or anything which is a difference between numbers to come up with interval data. So there could be 20 degrees versus 10 degrees, difference 10 degrees between the two, can be one set of temperature at a certain time of the day, then there could be a similar calculation at noon time or in the afternoon. So the differential or anything that is coming as a difference between temperatures from one time to another, or from one set of degree of temperature in Celsius to another, that can be obtained. That's all it is saying. Sometimes it gets confusing is because these are examples and one example don't fit all modeled within the interval data. That is the shortcoming of uh, explaining these data types. Because if you ask me honestly, there are more layers to it, and we are bringing some out of those subsets or sub layers of interval data that explains the nature of interval data to have different variants, and then to pull them out and bring it in the slide might be one of the reasons that there could be a slight disconnect. But the variance or the crux of it or the core of it would come back to or would attach to the class which we call interval data. Okay. So for that reason, I don't want you to get confused. These are some extra examples, but in the exams, when you look at the examples, you should be able to tie them to, let's say, the interval data as three examples, and anything that is laid out as part of the information on the slides that we are presenting. Uh, None of your exam final questions is going to be outside of this. So when we are giving some examples or samples that are brought to your attention in the slides, one of the reasons is that they could be something that they will use in the exams. The examiner usually uses these PDFs or these lecture slides and for building the questions, or for even for adding new questions, they're going to look at the slides. So that's what I'm trying to also bring to your knowledge. If you need help remembering what interval scales are, just think about the meaning of interval, the space between. Okay. So not only do you care about the order of variables, but also about values in between them. So it is saying that interval data would have other examples, such as the one we showed you, that calculates the differential or the difference between two values as the outcome. The same can be also, the same is mentioned in this para here, which is saying that interval data could also be considered something which is explained as differential, as well as what is explained as collection of info. So while interval data was giving a broader picture by explaining what it means, the practical application of it, which is more deeper layer of understanding different ways in which interval data happens, is explaining in the subsequent paras under this. One of the examples is the differential or the difference. Okay. There is little problem with interval. However, there is no true zero. A true zero has no value. There is none of that thing, but 0 degrees C definitely has a value. It's quite chilly. You can also have negative numbers. So it is also pointing to a few shortcomings and giving you exceptions, um, perhaps too difficult for you to remember if the examiner decides to give you this part, the last para, as one of the ways in testing you. I would say that that would be slightly unfair, but just reading through these slides would help. Who knows if this will show up also? Because one of the reasons that interval data has no true zero is because anything that you say no for or has a zero value, uh, if that's a common sense. No means zero, one means yes. Okay. Um, so that could happen in other sort of data sets, or how certain values are interpreted as zeros in qualitative analysis. But in interval data, generally there is no zero value. It has to be a number or anything that can be identified as as um, as something from which you can derive uh, results by comparing it with other numbers. Numbers means, even though zero is a number, but when I say number, it means it has to be, the actual typical numerics without the use of zero. So whenever you don't see a zero in some sort of interval data, with the exception that is explained at the very bottom, you should know that it cannot be an interval data. Okay. Ratio is even more easy to understand. Ratio means relative to one another, in the sense of how many times one is bigger or less, or in comparison, what could be the bottom line uh, difference in what is compared as the. Now, in the ratio, one thing you have to remember: what it is comparing to, whatever is compared to as being doubled or tripled, for instance, is a constant. So a constant cannot move. A constant would have to be a reference point. So in the ratio data, if you say scoring 40 points has twice the value of scoring 20 points, the ratio being 40 is to 20, where um, 40 is the whole, or 40 is the reference, and 20 points is with reference to 40 being twice as much, or 20 being a fixed point or something used as a reference in terms of ratio, would have a score of 40 being double of what is constant. That's how we do the measurement. It is one way of doing approximation, and another way of coming up with the impact of something against another something, which would not require for you to do more granular computation and collect lot of numbers, but rather using two or more numbers. There could be more complications in ratio analysis, which means that you can do ratio analysis using more than one operation of a constant against the variable. So if it is 20, 40, you're going to, okay, one thing that I mentioned, but it is just for mathematical reasons, for you to just grab an idea of how we write the ratios. Otherwise, it's not as important from, I mean, you won't be calculating things like ratios, or any kind of analysis in terms of identifying data types. Nothing of that sort is in the book for you to do as practical examples. So I'm just mentioning what the ratios might be useful for you to understand. Let me just show you uh, in terms of ratios. So let's suppose there is mm, a constant which is 20 as a number. So anything that has a value 20 and has a ratio to it being twice as much means that you're going to put 40 here. There could be another ratio that you can add to as 10. Okay. And each one of these would have a relationship, meaning that now you're going to create a relationship between 40 and 10 in terms of in another third variable that is going to add to your calculation. So 40 could be, mm, let's suppose 20 is the property value, okay? And it will become twice, let's say will become twice to make it 40, or it will double. And this will be the increase in the net worth. So if there are multiple ratios that you have to calculate, for instance, if 20, let's say, is the constant, it's the constant, okay? Then you've got 40 as twice, but in year, let's say 2020, and this is twice in 2021, and this could be decrease. So you've lost minus 10 times less in 2022. Okay, so a lot of times you will get data that would require other things like, year in play, okay, or there could be more. So the ratio analysis in this in the way that it is to be understood at this point is in the simplest format, and this could get more complex. So there could be even more values that can be attached to it, which brings or gives an additional meaning or additional context to 2020 or 2021. But the idea here is to understand the constant, and anything that is relative is going to keep getting added up on the right hand side. Nothing in the ratio is going to start from right to left. It's just the way you write in English. So this is one thing that is constant, other is relative. That's the ratio part. I'm going to take a break now, and I'll see you in a little bit. I want to next. I want to start with what we call mm, data collection methods. So we'll round it up quickly. It's going to be easier to do the next ones. None of the complexities that you saw in the data types. This is straightforward. We'll do this part, and then we'll do sampling, what sampling means, what are different types of sampling methods, and some of the illustrations on sampling. I'm going to take about 10 to 15. Okay, I'm back, ready to continue. Hopefully, everybody is back as well. And same question again. You can see my screen, you can hear my voice. Just give me a nod here, please. Anyone?
You're good to go.
Excellent. Thank you, Kristen. There we go. Now, there is something that we call mixed method or mixed method of obtaining both type of data types, like obtaining something that is quantitative and qualitative. So there is mixed techniques. I'll remind me that I have to direct you to a chart which will tell you, I'll give you a very easy to understand picture of what type of collection methods would be involving the both the data types, both quantitative and qualitative. So it'll give you a situation or the type of, the kind of, um, I guess, collection method that you will apply, which would emphasize that a part of the data would have to be quantitative, other has to be qualitative. But together, it will bring the outcome as one inference or one conclusion. When we apply both quantitative and qualitative methods together, we call them mixed methods. So nothing complicated so far on where mixed method is to be identified. And like I said, it's mentioned very clearly in the chart. I'll show you that chart also. Then there is a extra note which is showing here, which I'm pointing to. Um, it is explaining that one has to build what we call data management plan. As a researcher, you would be well advised that a proper planning of how you intend to use that data, analyze that data, depending on the nature and the type of problem which you have already identified, or collectively you have devised a methodology for using both quantitative and qualitative analysis and bringing data sets from there. You would have to list them or plan them in a data management plan. What data management plan requires is a deep understanding of some of the concepts we've discussed and others that are coming along, including the survey methods and the sampling methods. So all that will be actually will require for you to carefully, you know, build up data management plan. Um, and one of the things that will be included is how you would manage describes. It's a very short definition, and store those data. So this is additional thing. Analysis, we know. Manage means where you're going to what would be the sources or methods of obtaining the information. The descriptive part or anything that is written freehand as observations can be part of it. Even that is considered data, although it is not quantified, or even qualitative part of it is not going to be the best way, but rather your personal opinion is what we are referring to here. And the word is observation. That's when we say describe. Analysis, of course, requires quantitative and qualitative, and store those data. That's an additional piece, which means that it is your duty and your obligation to make sure that the data tables maintain integrity, or the data integrity remains intact, that's not polluted, or it is stored safe, and how you intend to do that, and what mechanism you will use at the end of your project to share and preserve your data. So I guess that's part of the planning, which is not part of this course, but it was worth mentioning. If you ask me, I would be interested, or at least learn a little bit more by uh, Googling it, at least to get a sense of what is included in data management plan and how it is built. So see, if you are interested, you can Google this data management plan, DMP. Um, so that's where we're going to finish up data types here for qualitative and quantitative. Um, one of the reasons when we did type of data, and this I spend slightly more time than I'm required to, is only because I want to make sure that it has some relationship to what we are about to learn later on. So to give you an idea, for instance, if it is a nominal data, like red is greater than blue is not possible. So there could be situations where you would have to be able to analyze the red and blue and all these, which would make it slightly more dependent on how you are going to put it in your analysis plan. Like, how would you analyze situations such as this? You cannot use averages, or you cannot apply techniques like median, like statistical methods would not work in comparison to this. And of course, then you have to look for alternative methods, which is also would require for you to do planning in how would you be able to interpret those colors. Like alone, red color would not have a value unless you use red color into how many times it was presented, or how many consumers, as an example, preferred red color, or why the insurance for the red colored car is more, depending on accidents, depending on their historic data that would have a relationship to the red color versus blue versus gray. So that means that even though these values are unique in itself, but it creates a problem which can only be resolved when you use methods like comparing with the frequency with which certain colors are appearing. Um, or in Skittles, for example, how many red colors you were able to find in a packet on the average from 10 packets. So that's the utility of it. And when you're doing sampling techniques, this part would be something you would be tested on, because the sampling methods would also have an impact on how the nominal data, or what volume of nominal data would be sufficient to come to the conclusion, like sample size, for instance, in such a situation. So every situation is unique, every calculation, every analysis is unique based on the type of data that is involved. In this one, this is a relationship relative to, like, brown colors, blonde colors. Again, it's not sufficient, but it has the ability to have some sort of, you know, um, some way. No, I'm sorry, this is nominal. I apologize, my God. Ordinal data. In this one, for example, where you might be able to use analytics like very likely, for instance, would be given a number one. Uh, Number one, how many times number one has occurred from a sample which you have to justify as being non-biased in the first place, for you to have opinions that could be more on of a personal nature, as in the case of ordinal data. So when you have this scenario, you have to figure out what could be the better sampling method. Sampling method in this case, it puts a lot of responsibility to be accepted as sufficiently wide enough or sufficiently homogeneous enough that it could represent a um, certain segment of your sample. All right. Um, anyway, you just have to come to the data collection methods. Now, whatever we are going to discuss here in bullet points, which is giving us an idea of, mainly two types of data, both quantitative and qualitative, can be collected from any of these ways in which collection is organized. Um, it could also be said that we can apply whatever we discuss right now in these different types. You can apply it virtually on the internet. So it becomes more important. I mean, if it was a physical, actual um, collection of information by visiting or on the ground, where you are physically going and collecting certain things, would have a kind of a similar sort of ways of collecting the data, except that when you put it online, it is to be considered as having the same sort of methodology. So it is not much different in that sense. However, I would be more inclined to explain it in the virtual sense of how we can do it online, because that is more useful for you. Observation techniques, that's number one. This is very unique in the sense that observation does not involve a lot of interaction with the subject of or the source of the information. Observation is something that is more personal, or it could, you could say, can result in getting some biased um, conclusions, because it is not vetted enough, or it is not complete enough, that would uh, that would be acceptable or generally acceptable, um, because again, like I said, it is an observation of sorts that um, may result in the collection, or when you are doing your observation, depending on how you have collected that observation. Like there are different methods of collecting or writing the observations. One of the methods is that you're going to follow strictly a certain dimension or certain criteria, or you would have a list to observe X, Y, and Z. That could be one. Second is freehand, we call memoing. It's just writing notes. Third is based on, the opinions collected from third party as observations, but slightly more interactive. So you have a script that you would use to stay within the confines of objectives. Otherwise, from the observations, we may be questioned on how we've derived, uh, the opinion, as well as a questionable part would be the sampling. Did we have a sample or enough of the same events or staged observations that can be compared or collectively be enough data that we can make that conclusion. So it is subjective and it is personal, and at times it is biased. Observation techniques would include social experiments that you see on video clips. It could be as simple as just observing a behavior of someone with a pet in a garden or somewhere outside, that you see how the dogs are being treated, or things like that. So that's your observation. It's very simple, but it could be as complex as interaction between in social experiments, particularly experiments of nationality interacting with the locals, that are not, that could be refugees, for example, could be religious, mm, attitude, or interaction, uh, behavior of something or someone that you observed physically, looking at the staged experiment. Now, experiments in the real sense of how they're treated in the research world is that there is a protocol to how you're going to make those observations. Protocol also means that these are rules which require for you to, first of all, get a legal consent, especially if it is human subjects. Then awareness or privacy issues are there. Then there is issues uh, of ethics. So all those come into play in observations. A lot of ground to cover. Then we've got surveys and polls. In surveys and polls, we have to first of all distinguish what is surveys versus polls, because it's put together. Polls are short questions, and they are usually very easy to answer. Plus, they are the type of questions which could be very would give a quick um, facts check or quick sentiments on something which does not require a lot of knowledge, or you don't need to or your subject don't need to have a specific background. Anyone can answer. So there's simpler questions, and basically they don't solve any problems. They don't require a whole lot of construction or techniques in putting the polls together. There is a differentiation and a chart which again I recall from the book, which is showing clearly showing in one column what are surveys versus what are polls. Those That chart is important because it's usually very typically it's appearing in the exams these days. So I have to point you to that. But before I forget, the previous chart I told you about qualitative, quantitative, and surveys and polls, I would want to open up the book quickly just so that I can show you where these are. And quickly you can mark the page numbers. And then I'd advise you to at least look him up quickly, just to when you're preparing for the exam. Where is my book? Okay. mm, I don't know who moved it. Um, Sorry about that. It's just going to show up quickly. Shouldn't be. Here it is. I didn't open it before. Should have left it open. Okay, I'm going to have to tell you the page number and the chapter. It's on. It's chapter 26, and the page is 357. So the difference between surveys and polls, uh, let's look at it as two pages. It's on page 358. You could see that this is giving the difference between what surveys entail versus what the polls are like. Um, and in the exam, usually what this give you is these two columns, but the heading wouldn't put the words like surveys or polls on it. So you would have to fill in these either survey, both of these as survey and polls. Like you can't put survey where the information about polls is giving details in this column. So to use this as a reference could be important. Surveys can take longer to answer. Mostly, survey questionnaire can gather opinions on multiple topics. Survey questionnaire can include several questions versus, you know, polls. So you know what this chart would help you with. It's for the exams. Okay. Then I want to show you the mixed method versus this is the chart. Let me show it as a single page view. So if it is questionnaire surveys, it would require mixed method approach. Okay, so there will be both qualitative and quantitative. Similarly, interviews would be more qualitative, documentation reviews qualitative, and this is with the highest weightage or where most of the questions can be qualitative. It doesn't mean that it would not apply mixed method. I mean, every situation is different. Even in interviews, there could be, you know, a brief survey that you can give them quickly, part of the interview, which would collect perhaps some of the questions can be quantitative. Anyway, qualitative is what prevails here in the interviews. Qualitative again in documentation. These are all collection methods, observations, focus groups, case studies. Okay. Surveys can be very detailed questions, and there is a method to how you design surveys. Sometimes it takes a very long time to design your surveys based on objective of your information, or you want to be you know, at times you, depending on the population or the target market you're surveying, sometimes it is human subjects that you are using. If you're doing the surveys online, then there is a method to it and there is a protocol, which means legalities. Online versus when you're doing it physically in the presence of your subject who's being surveyed. Surveys can also be, on subjects which are very sensitive and people don't like to answer as yes or no on certain questions, mostly qualitative, sentiment related, sensitive, based on religion, where you actually need to be subtle, and be very, I mean, you can't be too candid on asking certain questions which are of personal nature. So you have to just check to see if the subject um, is answering it, or they're phrased as such that they don't appear very um, personal, but have a way of slowly bringing somebody from one question to another that opens up more or allows more of the collection of information. If the subject is opening up or is answering certain questions, that gives you the cue that you can ask the next question, which could be even more personal. So you have to build those questionnaires. So they could be, and these are expert areas in the information collection. Surveys, questionnaires are handled by experienced professionals. Not just anybody can create any kind of questions and just throw it at someone to answer for. Uh, and then you need consent. You need the permission to use that information. You need to also ask the subject if they choose to stay anonymous or they don't mind. You can give them pseudonames, or there's a relationship issue here in the surveys as well. um, then we've got interviews. We'll see the survey questions when you look at some of the slides down here. You will see some of the ways survey questions are set. Where are they? Well, they're in the book. I'll show it to you in the book. They're um, different types or different ways or layouts of those survey questions. Okay. Then we have interviews. So interviews can be done virtually or they can be done physically, being a part of the group or somewhere that you have set an appointment between interviewee and yourself. Um, and interviews are important when you are focused on one individual as an expert or consultant, or a problem or the nature of your research is such that you are basically trying to collect the opinion or to deal with the subject matter that requires physical presence, not as a respect, but as having the close interaction to tackle a subject which require for you to ask certain type of information by observing the cues as body language, eye contact, comfort level, perhaps some of the ways in which you would write that or collect it by making it into a documented fact. You would not be able to do it at the same time, but it is something that is recorded or something from which you, if you have missed on some issues or you have not picked up the scent or um, the entire context of some topic, you may want to review it through your recordings. Um, Interviews are more personal, so the nature of the information that you collect is after the fact, which means after the event. or after the interview finishes, and then you would start to, basically extract it as qualitative or quantitative set of info. Then there is opinions as well that you will derive. Anything that is more collected after the fact or after the event. In the focus group, we are dealing with the subjects or some sort of set of people that either are dealing with or have a background which is homogeneous background between all the members in the focus group, or it could be a focus group which is more discussing a problem between individuals that may not come from homogeneous background, yet they would have opinion which would which will either reinforce the problem or highlight more of the problems, or would be the solution to those issues or those problems. So that's more intense, it's more interactive. But there could be, like I said, these focus groups are actually dealing with one specific problem or issue. It is different from interviews, it is different from surveys and observations. uh, Therefore, you have to be able to understand when a situation or a scenario is presented in the exam as a small para that is asking you to give an opinion on which could be a better way of collecting information in such and such situation. So you would say could be the focus group that is most appropriate, or interview could be more appropriate. Then we have got document studies. Document studies is basically just anything that is documented in books, in journals, in collection of facts from different sources. That's document study. It is more detailed, intense, and it is something which has a protocol or the type of information which may be qualitative or quantitative, except that in document study you build knowledge on top of, or you use document studies as if it is a source of information with reference to what you are working on as a solution for the problem or doing research on. So this could be supportive kind of data, and therefore it is not directly as considered as data collection method in the sense of how everything else is laid out, at least between observation, survey, interview, and focus group. Document study is slightly different in its nature and its usefulness or its objective. However, it is considered part of the data collection method, especially when you're writing books and you are giving citations and cross reference. Case studies is basically a situational study of something which may have a history or a background referenced as something that would reinforce or would support your theory or your or give solutions based on opinions. So case study in a is different from document studies in the sense that it can be a real situation, a real case that is extracted or used as a reference from the history, or it could be a situation that you would uh, get involved into in the mm, uh, or you have experienced in the ethnographic sense. Ethnography in research is when you are actually embedded in a social um, mm, situation of finding facts or building more knowledge without having a clear idea of how or where it would take you from your base question or base problem, like in a social setup in a village somewhere or in a country somewhere, or where it would take you more time to experience something from one idea that goes to another idea, and so it just builds up only because you're embedded there, you're physically there, and you derive your or you build your case study yourself. But here, the case study means using it as a reference or using previous experiences. But in both situations where you are involved in creating one versus where you are using somebody else's experience, there is always qualitative and quantitative data that you would want to collect. Next is the sampling techniques. Now, sampling, why do we do sampling? Because we cannot test every hypothesis or every situation with sizes of sample that can grow, um, or they can be a lot more data uh, in itself, which you will not be able to cover or gather. So it's a lot more of information that may not be as practical for you to use that. That entire population, that entire area of information, I'm just using it in a general sense, is too large and we call it a population. But population may have a characteristics. Any population that we look at from general sense of how most people understand it, we just call it target market or target of your study or the focus of your gathering of information from a certain type of resource. So the entire resource is too big, and where you have to uh, use the data collected from there for your analysis, you need to extract a sample that can represent that population in characters of that population, or based on certain specification, topic, whatever it may be, whatever subject it may be. The population is too large, and when you're extracting a sample, it has to represent the mix of those attributes or those focused elements that would have a synergy with each other, which would make it representative of a standard or a specific issue, or a size which has a nature and characteristics similar. So when you extract from it in pieces the sample size or the sampling of it would have to be representing somewhat those characteristics and everything else that is um, you know uh, combining those characteristics and attributes. So sampling itself needs to be non-biased for anyone to believe you as a researcher, to give an assurance to your client that it is this sample that you've extracted represents that population, and anything that you derive after obtaining that sampling from further analyzing that sample is going to be giving them a conclusive result or something that they can rely on as being true, in as being true enough or as being valid. Okay. So how do you do that, and how do you convince the client that the sample you took in the first place is this is besides being representative of it, like the method that you're going to use for collecting that, whether it was based on personal selection where you have individually selected from the sample something, or it would involve your personal preference of gathering that sample versus you have applied any kind of method or any kind of random methodology that would take away that bias or that ability for you to make judgment of your own, but rather look at it as if there is a method which randomly, mathematically or in some computational way was able to gather that sample. Okay, so that is sampling. One of the sampling techniques that we like to call non-biased sampling methods or techniques is probability sampling. Probability means the likelihood of something happening or not happening, or a chance of something occurring or not occurring, which is not controlled, and therefore it is randomized. So that is probability sampling. Here you could see that what random means is that the chance of finding one number as the number or just picking up something out of, let's say if it is a raffle tickets and they're just sort of put in a bucket and you just pull one out of it and there's hundreds 100 numbers in there. If you just pull one without knowing what that number is, that is random. The second time you put your hand, it gives a different numbers. So it is random. It is not like you have designed or know of what number you're picking. That's simple probability. Non-probability is when you are proactively or you are basically by way of your own personal judgment is selective about picking up the sample, making your own decision. That's non-probability sampling. Non-probability sampling is sometimes essential and random, or probability might not work in certain cases. And we are talking in this, think of it as an example of finding and we are talking human subject right now. I'm not talking about any objects or anything different than, so it's just purely human subject. So let's suppose it is a kind of a unique disease in clinical sciences for which you know it's very hard to find volunteers or find people with that kind of illness, and you have to go look search for them, or there could be uh, you know uh, there could be peculiar situation or certain situations that demand that you look for the subject because they're simply not available at all, or they require recruitment. Others could be sensitive matters for which not a lot of people are interested in participating, or or they don't want to be interviewed or surveyed because of the sensitivity of the issue. It could even be, you know, um, from countries like that has a dictatorship environment, and some matters cannot be discussed. So you can't just you have to recruit them. You have to give them some incentive. So that is by recruitment. One of the ways the word recruitment is used uh, is not typically what we generally think of it as human resource recruitment, or recruiters they use recruitment techniques. So those are different. That is human resource, it's personnel related. But in the other sense, the recruitment is used quite extensively as the word for recruiting subjects or samples that would involve specialized sample recruiters. And sometimes they're very expensive. Like we use some of them and they're very expensive. And so it is a technique and it is a kind of a profession. So in that sense, recruitment for finding the right type of sample would be another thing that you have to be mindful of. So non-probability sampling happens in those situations, as I mentioned. But mostly we are going to talk about probability sampling because it is more acceptable as means of satisfying the client to be able to think of these samples to have the credibility or have the attributes that would represent um, the population from which they are extracted. So this technique that we are going to apply in probability sampling is important, and anything that you do on your own mathematics of some sort is not going to work. Just follow what are the different ways or different terminologies used in sampling. Um, and we'd had students who had some issues with the probability sampling methods and methodologies only because they could not understand what we are about to learn. And I just want you to just know that there are two types, but within these two types of probability and non-probability, there are methods. Methods is what we call sampling methods: simple random sampling, stratified sampling, systematic sampling, clustered sampling, and there could be multi-tiered sampling, and there could be like seven more. So I'm just letting you know that they exist. And just because we are mentioning four of them doesn't mean that we are not covering all the sampling techniques. It's just that we feel that four of these are enough to give you an idea of what would otherwise be considered as the standard or the base level sampling techniques. Once you know these four of these, you would find that there are others which are subsets or the more deeper layers of cluster, systematic, and stratified sampling. So we're not covering that. But this is to give you non-probability sampling is very easy to understand. 1, 2, 3, 4, 5. This is just, I mean, you can even, I'll explain it, but it's not something that is um, got a method to it. So even though the word techniques is used, um, but let's not get there yet. Look at probability simple random sampling. Simple random, as I showed you the example, you have a mix of set of data or set of raffle tickets, for instance, and you just pull one out of it. And if it's 100 numbers, whatever you picked up random on random basis, that's simple random sampling. So don't have to worry about stratified sampling is where we start with. Um, stratified. Strata. Okay. Hmm. Okay. We won't be able to finish it, and I don't want to leave it hanging. So I would start with sampling techniques in the next class because there is a lot to cover. Anyway, let me see whatever is left. How many classes are we left with? Do you know? Did you even any one of you checked?
Three, yeah.
And I need to show you the sample exams also.
Yeah.
So let's look at where is schedule. I just want to get this schedule sorted out. I am falling a little bit behind, as you can tell, on finishing up some of the scheduled lectures that I should have finished or at least the module 2 took us a lot more time than expected. So where is it? Um, So I want to discuss this quickly with you before we go on a break, because I have to submit any changes for the coming week, or include anything that I need to finish, because we've got something else coming up for which I have to be ready for, and I have to and I have to finish this part on time. So we are on Friday, which is 10th today, and this is the 14th class. Apparently, this should have been business of research, but we are still doing this part, which is where we are covering the traditional research method. So there's two classes. You know what has happened here? We didn't miss anything. It's not like we missed any class. It's just that the first one that I did, which was on the 6th of January, was introduction. It should not have been counted as class one or the first class, because it was introduction and it was nothing that was taught really. We just discussed. So let's just say that this class we can exclude. So we can call class two as class one. So practically so far we have actually, if we say today is the 10th class, then it is the 9th class. Okay. So which is, no, I'm sorry. No, when we say 14th class, it is the 13th class. That means we've done 13 classes, which is where we are on Wednesday. So we are behind only one class. We are one class behind. So it's not too bad. What is going to happen now is that when we have the last class on the 17th, um, we will have to add another class on Sunday, Monday, 19th, 20th. On Monday, I have to do one extra class. So if you don't mind, I'm just going to add that to the schedule. It's just something that we must, provision for. And not just provision, I don't even think it's practically possible for, so it has to be a definitive class on the 20th. So I'm going to add one extra class on Monday. If you can just mark it on your side, it's not officially there yet on your side with the changes, but you can mark it. Okay. So that's the only thing that is going to be a bother for you, and an additional burden. So just keep that in mind. I'll do one more extra class. Anyway, I just want you all to have a good weekend. I think the sampling part we'll have to do on Monday, and the additional class will be on 20th. Good enough? Any questions?
No, that's okay.
So, okay, so no, I haven't given any assignment to any one of you. All I did is just tell you to look up some pages in the book, and whatever we learned on the query side, which required notes, I've placed all of them in your class. I forgot the name of the folder, but I think it was class work. That's where they are. So that's all the notes I've given you. No extra burden to you. The only thing that I feel that you should be able to start looking at as part of the homework, or the only homework I'll give you, is try to open up the sample questions, or see if you can. Don't go to the final exam. Please don't do that. Even though it's there, they shouldn't have put it, but don't open that. Just go to the practice Q&As. Uh, it'll be easy for me to explain quickly how the exams would work, or instead of me telling you a lot more about how it works, you can do or find things on your own and then ask questions later. So thanks again, and I'll see you on Monday. All right. Thank you.
Thank you.
Bye bye.
Sunod.
Bye. Have
Take
a good
care.
weekend.